Now we're recording again. Okay, now here's what we did to graph this function. If I want to graph this function, we've only got two zeros. The zeros or the x-intercepts occur when x is 1 and -3, because x equals 1 gives you 0, x equals -3 gives you 0. The y-intercept is easy to find. You plug in x equals 0 and you get 1 times 3, which is 3. So you've got this point, and this point. Now, if you've got 3 points, it sort of makes sense to try to fit a parabola, right? Well, if we try to fit a parabola, and I've got one in white, but I'm going to just kind of say, okay, well, maybe we want to come up to maybe about here and then come down here and go through here. Well, that doesn't work because this thing has to end up above the x-axis, and this parabola is going to end up below the x-axis. Now you might think, well, let's just turn around so we can go back up. If you turn around to go back up, you've got to go through the x-axis. And that'll be at some number other than -3 or 1. And if the graph goes through the x-axis at some number other than -3 or 1, then you're not going to get 0 up here, are you? The only way you get 0 out of this is if x is 1 or -3. Not sure I said that right before, but you know that these are the only values that can make this 0, because any other value of x won't give you 0 here if it's not 1, won't give you 0 here if it's not -3. So if you say, well, let's turn around, go through somewhere around x equals 5, it doesn't go through the axis because y isn't 0. If x is 5, you get 4 times 8, 32. You're sure not going to get 0. So what do? Well, the blue graph shows you. Blue graph has this shape. It touches the x-axis, just like, sort of like a parabola whose vertex is at the point 1, 0. Near 1, 0, this graph makes a parabola. Now, away from 1, 0, not so much, especially if you get all the way over here. A parabola doesn't do this, okay? But near 1, 0, it's a parabola. We say that x equals 1 is a 0 of multiplicity 2, because x equals 1, the 0x equals 1 came from x minus 1 squared. X minus 1 squared is a quadratic function. It does have a parabolic graph. So that, in a sense, 1 appears twice as a 0. And that's what causes the graph to do this, without going into more detail. And I like to go into more detail on that, but I'm not going to right now. Okay. So if you got an x minus 1 squared, the 0 at x equals 1 will act like a parabola near that 0. Not away from it, but near it. It'll eventually start distorting. If you had a 0 of multiplicity 3, that means whatever this value would be, you have a 0 here. If it came from an x minus 3 cubed, or an x minus some number cubed, it would have to act like the x cubed graph does at 0. Now, of course, in order to do most of this course and to understand what's going on, you need to understand the basic graphs very well. As I said, that's going to be one of the things you're tested on next week. And you need to understand automatically that that's what the graph of x cubed looks like near its 0. It flattens out. Okay, so there are some important aspects of graphs of polynomials, which is what we're getting into next week in the open math assignments. It'll be worth your time and trouble to be sure you understand as much of that as possible.